In this video, we're going to continue talking about section 9.7. We're looking at graphs of polar equations, and we're going to talk about symmetry in this video. So we've got three types of symmetry that we're going to discuss. Symmetry with respect to the line theta equals pi over 2. So you may want to think of this, if you're going to think about it in terms of rectangular coordinates, this would be like y-axis symmetry. And then with respect to the polar axis, so again, if we're equating this to rectangular coordinates, this would be our x-axis symmetry. And then with respect to the pole, this would be origin symmetry, or sometimes you'll see it written as 180 degree symmetry. So for symmetry with respect to the line theta equals pi over 2, we may have some point in the first quadrant r comma theta. Also on the graph would be a point in the second quadrant, which would have the coordinates r comma pi minus theta, or negative r negative theta. Okay, both of these points would also be on the graph, so that would have our theta equals pi over 2 symmetry. Now with respect to the polar axis, again, if we have some point on our curve r comma theta, we're also going to have a point on our curve that would be r comma negative theta, or negative r pi minus theta. And then with respect to the pole, our original point r comma theta would be on the curve, and we would also have this point on the curve, which would be negative r theta, or r comma pi plus theta. So that would also be on the curve. So we're going to use these facts to help us determine if a graph has symmetry. So when we're testing for symmetry in polar coordinates, if we're testing if it's symmetric over theta equals pi over 2, what we'll want to do is replace r comma theta with r comma pi minus theta, or you could also replace it with negative r negative theta. And then you want to check and see if you get the original equation back. Similarly, with symmetry with respect to the polar axis, we will replace r comma theta with negative r pi minus theta, or r comma negative theta. And with respect to the pole, we will replace r comma theta with either r comma pi plus theta or negative r theta. Now, for each of these cases, you have two options for what you want to replace r and theta with. I'm typically going to pick the option that has the positive r. So I'm going to replace with r pi minus theta when I'm checking for symmetry with respect to theta equals pi over 2. And then I'll use r comma negative theta when checking for symmetry with respect to the polar axis. And when I'm checking for symmetry with respect to the pole, I will replace r theta with r comma pi plus theta. And that just makes the work a little bit easier for us. All right, so sometimes you'll have to check for all of these three types of symmetry, but these three tests are not always necessary. Okay, they will guarantee symmetry, but there's a quicker way. If our function has an a sine theta in it, notice there's no coefficient in front of my theta, so if it has some a sine theta in there, then we know it's symmetric with respect to theta equals pi over 2. And if the function only has a cosine theta, again, notice there's no coefficient in front of the theta, then it's symmetric with respect to the polar axis. All right, and this is very similar to the symmetry of sine and cosine. Sine has y-axis symmetry, and cosine is going to have x-axis symmetry. All right, so let's take a look at a couple examples here. For part A, we've got f of x equals 5 sine theta. So we see that it only has a sine theta here. It's got an a sine theta. So we know that this is going to be symmetric with respect to theta equals pi over 2. In our next example, we've got 4 minus 2 cosine theta. So here's my cosine theta. Notice there's no coefficient here. So we know that this is going to be symmetric with respect to the polar axis. And lastly, this one, notice it doesn't have, it does have a coefficient here of 2, so we can't use our shortcuts. We're going to have to check. So we're going to check our 3 cases. So we're going to check with respect to theta equals pi over 2. So let's check that one first. So we're going to replace r comma theta with r comma pi minus theta. Okay, so we can rewrite this as r is equal to 4 plus sine 2 theta. So the r, we're just going to leave an r because we're replacing it with r. So we've got r equals 4 plus sine of 2 times, and we're going to replace theta with pi minus theta. Alright, so we have r is equal to 4 plus sine of 2 pi minus 2 theta. Alright, and we can simplify this using our sum of difference formulas. So we have r is equal to 4 plus sine 2 pi cosine 2 theta minus cosine 2 pi sine 2 theta. So sine of 2 pi is 0, so it's going to be 0, and cosine of 2 pi is 1, so we get r equals 4 minus sine 2 theta. Now we can see that this is not the same as the original because it's a minus instead of a plus. So not symmetric with respect to theta equals pi over 2. Next, we're going to check with symmetry with respect to the polar axis. So we are going to replace r comma theta with r comma negative theta. So we get r is equal to 4 plus sine of 2 times negative theta. So r is equal to 4 plus sine of negative 2 theta. And using our even odd identities, this would simplify to 4 minus sine 2 theta. Again, this is not equivalent to the original function. It's minus instead of plus. So this is not symmetric with respect to the polar axis. All right, and lastly, we are going to check with respect to the pole. So we will replace r comma theta with r comma pi plus theta. So we get r is equal to 4 plus sine of 2 times pi plus theta. So r is equal to 4 plus sine 2 pi plus 2 theta. Again, we'll use our sum formula for sine. So we have 4 plus sine 2 pi cosine 2 theta plus cosine 2 pi sine 2 theta. And again, this whole term here is going to be 0 because the sine of 2 pi is 0. Cosine of 2 pi is 1. And we get r is equal to 4 plus sine 2 theta. All right, so here we have an equivalent form which tells us that the function is symmetric with respect to the pole. All right, so the process is a little tedious, but once you do it a few times, it's really not that bad. You're going to have to use some of our stuff from earlier in the semester where we talked about identities. So you may want to have your identity sheet handy if you're a little rusty with those. And as always, make sure you're pausing the video if it's going too fast, or if you have questions that you want to write down so you can ask them later. And we will see you in the next video.